Hi, this video will talk about the inverse properties of exponential and logs. So here I've got them defined. If you have a log base a and you're raising a to the power x, then essentially our log base a and our a cancel out due to the inverse property. Alright, so these cancel out and you're essentially only left with what is in your exponent. Alright, but notice our base here, the base of our exponent, and the base of our log have to be exactly the same. They both have to be an a or a 2 or a 3 or an x, whatever our base is, okay? If our base of our log and our base of our exponential are exactly the same, then they cancel each other out and we're left with what's in the exponent due to inverse property. All right. Similarly, if we take a and raise it to a power log base a, all right, again they cancel out, but notice that the base of our exponent and the base of our log have to be exactly the same. If they are, and we're taking a and raising it to the log base a power, then they will cancel out and you'll only be left with what you're taking the log of. Okay, but the key here is that our bases have to match. All right, so let's put this into action. Here I've got a log base 5 raised to the 3x power. Notice the base of my log is a 5 and I'm raising 5 to the 3x power, so they match. Okay, my a's are the same. In other words, I have a 5 and a 5, so essentially these cancel out and I'm just left with what's in my exponent. So this would be equal to 3x. Okay, let's try another one. Log base 7 raised to the 2. My 7's are the same bases, so essentially these cancel each other out and I'm just left with what's in the exponent, a 2. Now this one's a little bit more complicated because I'm going to add something to it. So let's look at the second part. I have a log base 3 to the negative 4. Again, I have a base of 3 and a base of 3, so they will cancel each other out and I'll just be left with what's in the exponent, the negative 4. So I get 2 minus 4, which in this case would be minus 2. Note, if I had log base 3 to the 7x, okay, I can't really do anything with this. Why? Because the 3 and the 7 do not match. They have to be exactly the same. Here I have a 3, here I have a 7. So what that's equal to, we can do some manipulating and find out, but right now we can't really do anything with it. The inverse property does not apply in this case. So my final example. I've got 7 raised to the log 7, base 7 of 2x. So again, using my inverse property, as long as I have a base of my exponential is the same as the base of my log, they're both 7's, these cancel each other out and I'm just left with what I'm taking the log of, in this case the 2x. Okay, in the second part I've got 3 raised to the log base 3 of 4x. Again, the base of my exponential is a 3, the base of my log is a 3, so they cancel each other out essentially and I'm just left with what I'm taking the log of. In this case it's a 4x. But notice I had an operation in between, so I need to subtract the 2. So my answer would be minus 2x. Alright, so that is the inverse property of exponentials and logs, and this is very critical as we move forward. This is what we will use to actually solve exponential and logarithmic equations. Okay, so make sure you understand this. And once again, I know I've said it 100 times, but our bases have to match up. The base of our log and the base of our exponential have to be exactly the same before they cancel each other out.